This lesson is on graphing lines using slope. Let's consider an arbitrary line with slope m passing through the y-intercept 0b and an arbitrary point xy. By the definition of slope, from the previous lesson on slope, we can recall that slope is rise over run. Therefore, we would take our xy values of our 2 points and compare them to find the rise and the run. So, to find the rise, we could take y minus b to give us the rise, and we could take, in the same direction, x minus 0 to give us the run. So let's simplify that. That would give us m is equal to y minus b over x. If we use a little bit of algebra and multiply both sides by x, our x's will cancel out here and we'll be left with mx equals y minus b. Let's get y all by itself because slope-intercept form is defined to have y as being on its own on one side. So add b to both sides and you get y equals mx plus b. And that's what slope-intercept form is. So that's how it's found, and from now on, when you see an equation in this format, or maybe you want to make the equation in this format, it will be a little bit easier for you to graph. So let's check out how to graph a line that's written in slope-intercept form. Rather than finding points, we can now look at the relationship between the formats and notice that the numbers correspond for the slope and the y-intercept. So what is the slope in example 1? Y equals 2x minus 3. In the slope's position, you have 2. And we can translate that as 2 over 1, which means rise 2 and right 1. You can recall that for rise, positive means up and negative means down. And for run, positive means right and negative means left. And what is our y-intercept? Well, it's negative 3 based on the slope-intercept form. So let's start with those pieces of information. We can start with the y-intercept, and that is at 0, negative 3. And then we can follow the slope, the directions of the slope, based on the rise and the run. So we're going to travel up 2 and right 1. And we can keep traveling that way to form more and more points. All of these points should make up my line. Notice 2 over 1 could have also been written as negative 2 over negative 1, which would have meant down 2, left 1. Down 2, left 1 is also on the line. So now you can take a ruler out and connect your points. Let's try the next one. So here, this is no longer given in slope-intercept form. You want to put it into slope-intercept form. So we need to solve for y. Alright, well if we want y by itself, we want to move this 2x term over. So we want to subtract 2x from both sides. If we subtract 2x from both sides, we get negative 2x on the right side and the plus 10 is still there. Now we want to divide every term by 5 so that we have y by itself on this side and we have negative 2/5 x plus 10 over 5, which is 2. Notice that if you have negative 2x over 5, that's the same as negative 2/5 times x. So what is your slope and what is your y-intercept? Well, your slope is negative 2/5. You can treat that as negative 2 over 5 or 2 over negative 5. And you can use the following, up, down, right, left, to figure out how that slope looks. Our y-intercept is found also. So our y-intercept is 0, 2 based on the format. If you stuck a 0 in for x, you would see that y would equal 2. So let's use those two pieces of information to plot our graph. So we're going to start at the y-intercept. And that's at 0, 2. And then we're going to travel either down to right 5 or up to left 5. So down to right 5, or we could go up to left 5. Notice it gives you both points on the same line. Let's continue and graph some more of these. So here we want to graph both of these equations on the same grid. Let's check it out. Here we've got slope 1/2 and y-intercept, which is your b component of your y equals mx plus b, as 0, 2. Here we've got our slope to be also 1/2, and our y-intercept is different, making the line different, and it's at 0, -3. So let's see how this pans out. Start at 0, 2 for the first line, and then we go up 1, right 2, up 1, right 2, or down 1, left 2. Let's try the next one. That one starts at 0, -3, but also travels similarly. So up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, forming the line. There's much less calculation with this method. What do these lines look like? They are parallel. So notice that parallel lines have the same slope. Let's check out some other examples. In this question here, our slope is also 1/2 and our y-intercept is 0, 2. So let's graph that. 0, 2, up 1 over 2, up 1 over 2, or down 1, left 2, down 1, left 2. We've got slope to be -2. Remember, if it's a whole number, it's always over 1. So that could be either -2 over 1 or 2 over -1. And your y-intercept is 0, -3. So we're going to start at 0, -3, and we're going to go down to right 1, or up to left 1, up to left 1. Notice, if we keep going, we hit exactly a point on the other line. So let's keep going here. What do you notice about these two lines? Well, if you look at this box here and rotate it 90 degrees, you'll notice that it comes right here. Therefore, this is a 90-degree angle. What is it called when two lines have a 90-degree angle between them? Perpendicular! So you'll notice that perpendicular lines have this very property. Check out their slopes. One slope is 1/2, the other slope is -2/1. They are negative reciprocals of each other. You can also multiply the slopes to check. What's 1/2 times -2? 2's cross out, you're left with -1. So if your slopes multiply to -1, your lines will be perpendicular. Let's see if the following works as well. Here we've got slope 2/3 and y-intercept 0, 2. And here we have slope -3/2 and y-intercept 0, -3. Let's just check. Do our slopes multiply to -1? Are they negative reciprocals of each other? Why, yes, they are. So therefore they should be perpendicular. And let's try it out. Let's graph the first one. So the first one, we start at 0, 2 and travel up to right 3 or down to left 3. And the second one, we start with 0, -3 and travel down 3 right 2 or up 3 left 2. And there you go. You've got perpendicular lines. So, without graphing, how can you tell if lines are perpendicular or parallel? Well, as we just learned, you can basically just look at their slope. So this question here, they are asking which of these are perpendicular and which of them are parallel. So let's work on finding the slope of each one. Remember, when you have this format, y equals mx plus b, the coefficient of the x will be your slope. So let's make sure each of them are solved for y. These two are, but this one isn't. So solve for y, subtract your x from both sides. Y equals -x plus 1. Here we've got y equals -x plus 2, and here we've got y equals x minus 1. So what's our slope in the first one? It's -1. Our slope in the second one is also -1. Our slope in the third one is 1. So let's compare the slopes. We'll notice that the first two are the same. Therefore, the first two lines are indeed parallel. Okay, if we multiply two slopes and we get -1, then the lines will be perpendicular. So if we multiply these two, the second and the third, we'll get a slope of -1. So those will be perpendicular. And then also, if we take the first and the third, that will also be perpendicular. So if we labeled this A, B, C, you could say that A is parallel with B, and that's all we have for parallel lines. But then A is perpendicular with C, and B is also perpendicular with C as well.